Hello class and welcome to lesson 1.6a, measures of spread. Okay, so we're going to warm up today just to go over last day's calculations of the mean and the median. So what we need you to do, folks, is take a look at your textbook page 136 and you'll see there's a chart there that talk about two different basketball teams. Okay, and they're taking a look at different players and their heights. Okay, so pause the video, do the calculations. When you're done, please unpause it. Please actually pause it and do it, guys, okay? All right, welcome back, ladies and gentlemen. Hopefully you've got your answers done. Let's take a look what you got for Falcons. So first of all, for the Falcons, ladies and gentlemen, you take all their heights and you add them up and divide by the number of players, which is 7. Hopefully, ladies and gentlemen, for Falcons, you got an average height of 165. And the median height, folks, don't forget to put them in order. Remember for median, folks, two other pieces of terminology we learned were second quartile or the 50th percentile. So you put them all in order. And you have that the median for the Falcons was 165. Let's take a look at what you did for the Ravens. Okay, so for the Ravens, the mean you should have 165, and the median should be the second quartile or the 50th percentile is 166. Okay. All right. So notice, ladies and gentlemen, with this two set of data, that the mean was the same for both the Ravens and the Falcons. But we have different numbers. So sometimes we have to do more statistical analysis. So we have to take a look at what's called the spread of the data. Okay? We're going to take a look at different measures of spread in today's lesson. Okay, so for today's expectation, folks, measures of spread. And we're going to learn 3 different measures of spread today. Okay, the first one is the range. We've already taken a look at that. But the range is the highest data, subtract the lowest data. So if we take a look with the Falcons, ladies and gentlemen, there's a 37 centimeter difference between the smallest and the largest player, whereas with the Ravens, there's only 7. So I would say that the Ravens has a more consistent height because there's only a spread of 7 centimeters. Okay, so now we're going to take a look at a new terminology called the IQR, and you'll need to know this for your test, folks. It's the interquartile range. Okay, so what you need to do is take your third quartile and subtract your first one. Okay, so all you need to do is find that data. So here's how you do it, ladies and gentlemen, right here below. Okay, so to find Q3 and Q1, first of all, find the median. And that cuts the data in half. Okay, Q1 is the median of the lower half. So cut the lower values in half and cut the, for the Q3, you cut the upper values in half. All right, so let's take a look at how we do this. Okay, so for the Falcons, ladies and gentlemen, we know our median is 165. Okay, so if we put them in order, look on your chart, folks, you put them in order, the median is 165. Q1 is 148, if you take a look at your data there, and Q3 is 181. Okay, so it's halfway between the upper half. Okay, so to find the IQR, this is what you need to know how to do. You take the Q3, subtract Q1, and you'll notice that 33 is your answer for your IQR. What does that mean? That means that most of your data is within 33 centimeters. That's a wide spread. Okay, basically, if you've got someone who's really short and you've got someone who's really tall, they're like kind of almost like outliers. So they kind of fit outside the general data set, which is in the middle. Okay, so please understand that we're looking for the middle amount of data. Okay, whereas the Ravens, ladies and gentlemen, we have a median that's 166. Okay, split that in half. So Q1 is 163. Q3 is 166. Look on your chart. Okay, and the IQR, which you need to measure and be able to do this on your test, is 3. That means that with most of the players are within 3 centimeters. okay, in change of height, okay? A graphical way to represent this measure of spread is called a box and whisker plot. Okay. Now the one thing you've got to remember about a box and whisker plot is it's centered around the median. Please mark on your page here, see text page 141. Okay. So if you take your data, ladies and gentlemen, and we go to place this on a box and whisker plot, okay. I have to set up the same scale so we can compare it. Okay, so if you take a look at the bottom here, see if I can fit both of them on here, just barely. Okay, so if I know my range is 145 to 185, notice with the Ravens, folks, the box is much smaller because most of the people are similar height, whereas the Falcons is really spread out. Okay, so notice Q1 is the outside of your box to the Q3, especially for Falcons, it's easier to see. Okay, the lowest data point, folks, is right here. Okay, and the highest data point is here. Okay, and in the middle, which is your median. So median is here. For the Ravens, the median's a little off. So it is, I think, help me out, was it one, just looking back on my notes. For the Ravens, the median was 166, okay? So the median is right here, okay? Now this is interesting because Q2 and Q3 are at the same spot here, Q2 and Q3, because they're similar heights there, okay? All right, so that's a box and whisker plot. Next day we're going to show you how to do that on the graphing calculator. Okay, here's what it looks like if you do on the graphing calculator. So notice here is Q1 for both of them. Okay, here is Q3 for both of them. Notice there's a double line there though, okay? And in the middle, Q2. So the Q2 and Q3 are the same for the Ravens, okay? And we're going to show you how to do box and whisker plot. You can also find apps on the website that do it for you if you don't have a graphing calculator, but that's what we're going to use next day. All right, so previously when we talked about measures of spread, we always looked at the median as the center. Now we will use the mean as our center. Okay? All right, so what we're going to do is this is setting up for standard deviation. You may have heard that terminology before, but now we're getting into looking at that. So from page 136, the Falcons' mean was 165. Okay, how far is Laura from the mean? Well, Laura's pretty tall. She's 165, so subtract the mean. So it means she's got 18, so she's 18 centimeters taller. Okay, that's a large spread. Okay, how far is Colleen from the mean? Okay, well, Colleen, she's smaller than the mean. So notice it says negative for your answer. So that just means she's 19 centimeters shorter. Okay, now the problem is we've got some positive values and some negative values. So we need to find a way to do measures of spread so they don't have negative numbers, because these almost equal each other out, being 18 taller or 19 shorter. Okay, so now we're going to lead us into what's called deviation. Okay, and then we'll get to standard deviation. Okay, so deviation, folks, is a subset of standard deviation, and it says how far is each data point from the mean. Okay, so we take a look at Laura. Laura was 183. You subtract the mean, so 18. That's what we got, 18 taller, 18 centimeters taller. Whereas Colleen was pretty short. She's 19 centimeters less. Okay, don't copy the rest of this. Just listen. Okay. So, what are the deviation for the overall team? Well, the problem here is we've got some negative values and some positive values. Okay. So what we need to do is we could average all the deviations, but some are negative. So we have to cancel, they would cancel each other out. Okay? So we could use the deviations with absolute values and then average them, but statistically, everywhere they plot, they'd make your life more difficult and they would come up with something called standard deviation. So this is why we have, and this is probably the most popular measure of spread. Okay? And this is what I actually want you to write down right here. So this box right here. So standard deviation, it's the square root of all deviations. When you take the square root, that's okay. And the reason why we can take the square root, folks, is because if you notice in both of these examples, folks, that we've squared it. So in both those cases, 18 squared and negative 19 squared, they would get to a very similar number because they're squared. Okay, and we're going to use technology for this 90% of the time. Okay, and for your first unit test, you will use a TI-83 calculator to help you. Okay, otherwise, doing it by hand, this is how long it takes and how tedious it is. Okay, so please don't do it by hand. Okay, so taking a look, what you'd have to do, you take each data point, would subtract it from the mean. So there, for example, is, I think, Laura and Colleen there, so that's their differences. Then you square it. Notice that when you square it here, folks, in this next column, it eliminates the negatives. So that allows us to get a sum of the negatives, okay? And then here is our standard deviation formula, okay? Again, a graphing calculator will do this all this work for you as long as you type it in, okay? So you take the sum of all these, which we have right here, okay, and you take the number of data point and subtract 1. So the standard deviation is 15.9, okay? And that was just for the Falcons, okay? So if we have grouped data, okay, you have the same formula, folks, and we're going to use technology for this. This is too hard to do by hand, but if you want to do it by hand, let me tell you, it is tedious and it takes way too long, and you get such a high error, potential of room for error. So you have, with group data, folks, you have to take a look at the frequency, you have to get the midpoint, you subtract it, then you have to take a look at summing it. Okay, so again, I would recommend that you use the technology. Some of you like TI-83, some of you don't. I am here to help you. The great thing about a flipped class is you can use them the entire time, and I can help you during class. Okay, now, this is what I want you to write down. What does standard deviation tell us? How much the data is spread out. Okay, so what you need to know is that most of the data is 68% lies within one standard deviation of the mean. This will make more sense, folks, if you take a look in your textbook at page 425. What I also want you to remember and write down, please, okay, the larger the data, the more spread out it is. Okay, so the larger the data point, the larger the standard deviation, okay, the more spread out it is. Sorry. Okay. You can't just look at standard deviation, though. It has to depend on your frame of reference. Okay. So marks, for example, marks can be spread out because they have values above and below a mean, right? So a standard deviation of 25 isn't too bad when you take a look at marks. But you're taking a look at jet fuel, where the average amount of jet fuel you use is 150,000 or 15,000, like this example. That is too close together. Okay? And the last thing I want to do... And the last one I want to take a look at is variance. And variance is attached to standard deviation, and you just don't square root it, okay? So it's tied in with standard deviation, and I don't want you to worry about it. It's on your formula sheet. Okay, next day, here's what we'll do, class. Next day, we'll be using technology and for the next lesson, and here is your homework for today, page 148, numbers 2 to 4, 6B to D. Have a great day.